By 2030, EVs will dominate the global car industry, reshaping transportation as we know it. But to make this dream a reality, we need an incredible surge in the production of highly efficient and affordable batteries. Lyten, the Silicon Valley battery tech company, has just emerged from several years of top-secret Defense Department research to unveil a game-changing battery technology known as lithium sulfur. What makes this new type of battery so extraordinary? Well, for starters, it's not just cost-effective, but it also holds tremendous potential for the future of battery storage. At a mere $17 per kilowatt-hour, it's a gem. And that's not all. Lithium sulfur batteries might just push solid-state batteries aside and become the next big thing in battery technology. So, in today's episode, we are diving deep into the world of lithium sulfur batteries and exploring why this electrifying discovery is poised to revolutionize the field of battery storage. Let's take a closer look at the magic happening inside these batteries. Traditional electric vehicle batteries rely on charged lithium ions to perform the essential work. When connected to a supercharger, these ions move through the electrolyte, cross the separator, and coat the anode. Upon accelerating, they reverse direction and form strong chemical bonds with the cathode material. What makes it fascinating is that current EV batteries can only hold 0.5 to 0.7 lithium ions per cathode material. However, sulfur atoms have the incredible ability to accommodate 2 lithium ions, presenting a groundbreaking advancement in battery technology. Suddenly, you're looking at triple the range or a battery that weighs 1/3 less, and the excitement doesn't stop there. Stellantis, a prominent player in the automotive industry, recently announced its investment in Lyten on May 25th. This move aims to fast-track the commercialization of Lyten's 3D graphene applications for the mobility industry. This includes the highly anticipated LitCell Lithium Sulphur EV battery, as well as lightweight composites and novel onboard sensing. Lyten, known for being a pioneer of three-dimensional, 3D graphene, is leveraging the unique tunability of this material to unlock enhanced vehicle performance and improve the customer experience. But what truly sets Lyten's lithium sulfur batteries apart from the traditional lithium-ion ones is their environmentally friendly nature. These batteries want to decarbonize the transportation sector. They don't rely on nickel, cobalt, or manganese, which means they boast an estimated 60% lower carbon footprint than today's best-in-class batteries. In fact, they have the potential to become the EV battery with the lowest emissions on the global market. Not only that, the raw materials for lithium sulfur batteries can potentially be sourced and produced locally, promoting regional supply sovereignty and mitigating supply chain disruptions. It's a win-win for the environment and the economy. Now let's take a closer look at how a lithium sulfur battery works. A lithium sulfur battery has 2 key components: a lithium metal anode and a sulfur cathode. During charging, lithium ions move from the anode to the cathode, creating an electrical current. Sulfur undergoes reactions with the lithium ions and electrons, storing energy as lithium polysulfides. The lithium ions remain in the cathode, while the electrons flow through the circuit. During discharge, the stored energy is converted back into electricity as lithium ions return to the anode, and the sulfur cathode reverses the reaction. All these intricate movements of lithium ions and electrons during charge and discharge cycles enable the lithium sulfur battery to store and release energy. One remarkable advantage of lithium sulfur batteries is their higher energy density, meaning they can pack more energy into a smaller size. Combine that with their cost-effectiveness, thanks to the low cost of sulfur compared to metals used in lithium-ion batteries, and you've got a winning combination. However, it's worth noting that lithium sulfur batteries have a shorter lifespan. But fear not, researchers are hard at work to improve their durability. Overall, they hold the promise of offering greater energy storage, lower costs, and improved sustainability. Despite several obstacles that have held back this innovative chemistry, engineers have been hard at work finding solutions. The low electrical conductivity of sulfur? Solved. They've cleverly attached sulfur atoms to highly conductive carbon structures like nanotubes. The issue of cathode expansion? Not a problem anymore, as it can be overcome with techniques similar to those used in solid-state battery technologies. But the third challenge has proven to be a really tough nut to crack. Imagine lithium ions playing a game of Red Rover, heading back over to the anode. but sometimes they bring along sulfur atoms, depleting the cathode and ultimately leading to battery failure after only around 100 charging cycles. That's fine for short missions, like an impressive 11-day solar electric airplane flight. But electric vehicles require batteries that can handle 1,000 to 2,000 cycles. Enter Lyten, the trailblazer with a patented process that constructs a cathode using three-dimensional carbon graphene. Typical graphene sheets are only electrically reactive on their edges, but Lyten's proprietary three-dimensional graphene is a game-changer. It consists of zillions of tiny planes of graphene that form millions of little boxes in various geometric shapes. These amazing boxes effectively cage sulfur atoms, solving the conductivity problem, providing space for sulfur expansion, and preventing it from running off with lithium. Lyten boasts an impressive 400 cycle life, with the electrolyte being the only limiting factor. So how does Lyten create this marvelous three-dimensional graphene? Well, it's a bit like the semiconductor industry making silicon wafers. This process assembles the carbon atoms into complex three-dimensional graphene structures. The liberated hydrogen can be sold or used to generate about a third of the energy required for the process, making it environmentally friendly. Lyten hasn't spilled all the details about its electrolyte just yet, but one thing's for sure: it contains no oxides. That means the risk of fire is practically non-existent since there are no oxygen atoms present. Lyten has even conducted extreme tests, overcharging cells and driving nails through them. And guess what? The temperature rise didn't exceed 20 degrees. These batteries operate flawlessly in temperatures ranging from 20 to 140 degrees Fahrenheit, support fast charging, and require minimal heating and cooling. Using existing equipment, they can produce cylindrical, pouch, or prismatic lithium sulfur battery cells in half the time. The secret? The lithium is introduced as a coated metal anode, rather than being part of the cathode. This eliminates the need for the initial charging time required to form the lithium anode. Lyten has collaborated with 5 automakers and plans to select a gigafactory site in early 2022 to kickstart the incorporation of their cutting-edge lit cells into vehicles starting in the 2025 or 2026 model years. With the traditional lithium-ion battery materials facing critical shortages for electric vehicle manufacturing, it offers a nickel-manganese-cobalt cathode alternative that supports the global transition to electric vehicles on a mass scale. Lyten aims to provide its customers with secure supplies of high-performance and environmentally sustainable products, while also helping auto manufacturers take advantage of incentives in the US and Europe, such as those mentioned in the Inflation Reduction Act. And guess what? In 2023, Lyten's goal just got a significant boost with an investment from Stellantis. Stellantis, a frontrunner in the automotive industry, launched Stellantis Ventures in 2022, a venture capital fund specifically designed to support sustainable automotive and mobility startups. Stellantis and Lyten have formed a partnership that supports Stellantis' Dare Forward 2030 plan to reduce CO2 emissions, achieve carbon neutrality, and meet performance targets. Lyten's revolutionary technology, including lithium sulfur batteries and lightweight composites, aligns with Stellantis' goals. Lyten's lithium sulfur battery is seen as a promising solution for mass-market electric vehicle adoption. Furthermore, Lyten's material technology is well-positioned to address the crucial need for reduced vehicle weight, an imperative step for the automotive industry to achieve carbon neutrality. In addition to supplying EV batteries, Lyten is already collaborating with previous customers to introduce lithium sulfur batteries and 3D graphene-infused composites to specialty markets in 2023. Moreover, Lyten is partnering with strategic investors from various industries to apply their game-changing Lyten 3D graphene materials in decarbonizing sectors beyond transportation. Experts are optimistic about the timing of lit cells, a low-voltage battery replacement, which could have significant implications. Safety testing for emerging cell chemistry typically spans several years, but the potential launch of lithium-sulfur batteries in mobile devices and defense applications could expedite their introduction. Now, we'd love to hear your thoughts. What do you think about the incredible energy density and long lifespan of the Lyten battery? How do you envision this technology transforming various industries, from electric vehicles to renewable energy grids? We encourage you to share your opinions, ideas, and questions in the comments section below. If you found this video helpful, please like it, subscribe to our channel, and click the notification bell to stay updated with our future content. Thanks for watching. See you next time.